on this table, you can see that I've already filled it in. All I did is type log of each one of these numbers into the calculator. So you can see I have log 2. I know that log 1 is 0 because anything to the power of 0 is always 1. So remember, logs and exponentials are inverses of each other, and the exponent of the exponential becomes the answer to the log. So if I have x to the power of something and I need it equal to 1, I have to have that 0. And then log is base 10. So if I have log base 10 of 10, then that just becomes, the answer becomes my exponent on 10, which would be a 1. So those are the two that I know for sure. And then for the others, we just type it into the calculator. Log 1, log 2, log 3, etc., etc. So what we're doing today is we're using this table to complete each one of these statements. So if we have log of 3, which is this one right here, and log of 5, which is this one right here, we have 0.477 plus 0.699. Let me do this instead. This plus this. And so again, we're just going to use our calculator in the table. So log of 3, 0.477 plus 0.699, and that's 1.176. So 1.176. So for the second one, we're taking log of 3 times 5. Now this is not the log of 3 times the log of 5. It is the log of 3 times 5. So 3 times 5 is 15. So all I'm looking for is what the log of 15 is. That's 1.176. All right, so again, for log of 1 plus log of 6, so log of 1 is 0, so this is going to be whatever log of 6 is, so this is 0.778. And the other one that we need to have is log of 1 times 6. So again, we're multiplying these first. Think about PEMDAS, do what's inside the parentheses first and then do everything else. So 1 times 6 is 6, so log of 6, 0.778. Same thing here, log of 10 is 1, log of 2 is 0.301, so this is just going to be 1.301. And then we have log of 10 times 2, which again, think about PEMDAS, you're going to do your parentheses first, so 10 times 2 is 20, and then do the log. So the log of 20 is 1.301. So what do you notice about everything? Well, I notice that when I add the two logs together, and then when I take the log of those two numbers multiplied together, it equals the same thing. So if I have log of 3 plus log of 5, it's the same thing as those two numbers multiplied and then take that logarithm. Same thing here. This number is the same as this number. So I took this number and multiplied them together and then took the log of that and I get 0.778, which is the same thing I get when I just add them over here. Same thing down here. If I take the log of 10 and add it to the log of 2, it's the same thing as if I multiplied these two numbers together first and then took the log of that number. So what can we conclude about log of m plus log of n? Well, it's the same thing as log of m times n. So we're going to do the same thing here. We're going to make a conjecture, which is an educated guess. So write down what you think it would be. And then on the next page, we're going to test that conjecture. So here we have log of 6, which is 0.778, minus log of 2, which is 301. So this will be 0.477. And then on this one, we're taking the log of 6 divided by 2, which again, we're going to do this part first. So 6 divided by 2 is 3. And then we're going to take the log of 3, which is 0.477. Same thing down here. We're going to take the log of 15, which is 1.176, and we're going to subtract the log of 3, which is 0.477, and we're going to get 0.699. And then we're going to do the same thing, except here we're going to divide first. So 15 divided by 3 is 5. Log of 5 is 0.699. And then same thing here, log of 20, 1.301, minus log of 2 is 0.301, so that just leaves us with 1. And then log of 20 divided by 2, that's 10, so log of 10 is equal to 1, not 41, 1. So again, what do you notice? When I subtract each individual log, I get the same thing as if I divide those bases and then take the log of that number. So what can we conclude about log m minus log n? Well, that should be the same as log of m divided by n. The next two are graphs, so we're just going to copy and paste. Eventually we'll get this. There we go. All right, I'm going to make this graph black. So if I just click and hold on that, I can change the color of that. And then I'm going to go back and I'm going to make this one interesting. Put this one under here. And you can see I can turn those on and off just by clicking on them. So even though, oh, sorry, this is supposed to be. So when I turn that on and off, you can see that it's the exact same graph. Even though the equations don't look the same, the graphs are exactly the same. Okay, so for the next one, we'll do the same thing here. Change this one to a different color. We'll change this one to black. And then we're going to do the same thing. The only difference now is that we're going to have our -1 out in front. And again, you can see when I turn those graphs on and off that they are in fact the same graph. So even though the equations look different, those graphs are exactly the same. So what can we conclude about these two graphs? Well, they're the same. So what does that mean about the two equations? It means that they're also the same. So if I have the statement log of m to the power of k, all I'm doing is k times log of m. Okay, so the exponent just comes down to the front. So these are the three properties that we've talked about today, and they're exponential equivalent, right? So the reason that we add these together is because these represent these represent exponents. So if you have two of the same bases that are being multiplied together, so you have the same base here and the same base here, what do you do with their exponents? You add them. So that's why we add the log here and the log here. So this is the product property. This is the quotient property. So if you divide, it's equal to log base b of x minus log base b of y. And these two are equivalent. So this, if I see this, I can assume that this is true. And if I see this, I can assume that this is true. Vice versa for this one as well. So if this is true, I can assume this is true. If I know this, then I can assume this is true. And so I can rewrite back and forth between these two. So we have the product because we're multiplying. We have the quotient because we're dividing. And we have the power because we have the exponent. And again, this one, same thing. So these two are equivalent to each other. I can rewrite them and move them back and forth. So the last few problems on here are just rewriting these as a single logarithm. And then simplify, so actually calculating this. So you should have a numeric value for each one of these. And then here we're expanding and then rewriting this log as the sum or difference of two different logarithms. Okay, so those you should be able to do on your own. If you have questions, let me know.